Basics of blast wave theory. WEEK3. Energetic materials. Explosive performance data. Shock waves.
So these kinds are the energetic materials. They got their names. Pyrotechnics, their main application is initiators, timing devices and fireworks. These timing devices are very important in the proper functioning. For example, if you want to dig a mine or blast some rock, you need to have some kind of a timer, safety timer, so that those people who are planting it can go to safety. The burning rate is less than 1 kilometer per second. They produce low energy, low compared to the lower categories. Propellants, they are used in propulsion devices, airbags, especially in our cars. Interesting thing, they serve as fire extinguishers. When the jet airliner, the passenger airliner engine or catches fire, then these propellant fire extinguishers are fired and they blow off the fire. So there are some application. Again, the burning rate, they deflagrate, and the burning rate is less than 1 kilometer per second. Explosives. Now these are used in blast and fragmentation warheads. They are used in metal forming and welding, demolition, excavation, mining, oil extraction. Detonation velocity more than 1 kilometer per second. Then we have their categories. One is called primary explosives and the other one is called secondary explosives. Now there are so many definitions associated to primary. Number one is, I think the topmost or the most important definition is, primary explosives are those which are sensitive than PETN. In high explosive or secondary explosive, those explosives which are less sensitive than PETN. Now this lead azide and lead stiffenate are very sensitive to friction, shock, impact. So they find a lot of applications in initiating devices along with pyrotechnics. Now these are some names of high explosives. The oldest one is TNT, trinitrotoluene. RDX, many names, but what I believe is more authenticated is Royal Demolition Explosive. Basically the chemical name is quite different. And HMX, His Majesty Explosive. So these are the names given to them. If we look, we can categorize these among or compare them with their performance parameters, and here are their performance parameters.
How about the PE4?
PE4, that is basically plastic with RDX. You see, this basic is RDX, and they introduce some plastic to bind it. Now interesting thing, this TNT melts, RDX melts but at very high temperature, it reaches its flash point. HMX similarly. Now usually what this one was invented first, TNT was invented first. Now, different composition. RDX is more energetic than TNT. Now, this RDX is difficult to bind. Bind means to pack into a certain shape. When you want to have a warhead, for example, the warhead might have a specific shape, cavity. We will later learn why these cavities and special shapes or shaping is required. Now, one introduced was composition B. Composition B, and it was 60% RDX and 40% TNT. Yeah, sometimes they call it 1% wax also in this one. Now, what they do, they melt TNT, because TNT melts at 80.2 degree centigrade, it melts. So, it is quite low melting temperature. You can use boiling water to melt this, and then you mix RDX with it, and now you get kind of a slurry which you can cast into any shape. Now, first these are the very first composition which were produced, but later when polymers came into industry, different kind of plastics, polymers which you can cure, then these polymers were added to RDX, to HMX. Now, there are different series, PBX series and LX series also. 9404 is very familiar. The LX series also, there are certain numbers in here, and these 4 numbers are also changing. So, you can find a lot in literature. So, basically these are also called plastic bonded explosives. CE4 is one of them. So, what they do, they take this RDX or HMX. RDX is basically in PE4, RDX powder mix with some polymer and then cure it. Now, why this is PE4, why it is so popular PE4? Because you can make any shape through hand. I mean, this can usually be used for demolition. The armed forces use it to demolish for defensive purpose. Also, when the service life of the ammunition is over, then they also use this. Now, this is very easy. You just take a lump of this explosive and you press it somewhere in there. Now, the interesting thing is that if you want to do some scientific work with PE4, then you would be in trouble. Why? Because once you press it through hand, a strong man press it, the density gets a bit higher. A weak person like me try to deploy it or press it, the density would be a little bit lower. So, it would give different performance. So, for scientific purpose, if somebody want to use PE4, then you need to introduce a press to maintain your quality, maybe hand press or some other press. So, you have to be very careful while doing some scientific investigation. Did I answer your question? Okay. Now, maybe we come back to these. Here I have given some of the characteristic parameter. The performance parameter, first one, this D especially, the detonation velocity and the detonation pressure, they depend upon rho naught. For example, for TNT, if you look into the literature, the value I mention here is for 1 point something density, But if you look, you can find also granular TNT, the performance parameters would be altogether different. So when you increase this density, yeah, up to certain level, if you apply a press and you very much compress it, it may not be detonated at all. Later we would see through this phenomena also how the detonation take place. Now this table I have given just to give some idea what kind of pressures we are going to confront, what level of pressures would be in here, and what shall be the detonation velocity or the combustion rate, so to say. In here you see these two are primary explosives, the rest all are high explosives. Okay, in their application, these are also called priming compositions. Lead azide and lead stiffenate, they are sometimes called priming explosive. And this TNT, RDX and other these plastic bonded explosives, yeah, here I have mentioned this PBX also. Now these secondary explosives, you would see the name booster for tetrial, maybe booster for PETN. Now what is this booster? Booster is explosive, but because of its application nature, we call it booster. Later, I think when we try to define and describe detonation phenomena, we would go into a bit more detail in there. Now, before we proceed further, it's better to try to understand what shock waves are. Now, the example one can give is of a runner and traffic. In traffic, if almost equidistant cars are running and one car, because of some obstruction, pull the brake, then what happens? There is a kind of lag in seeing and action. So the rear driver also pull the brake, and all the cars or most of the cars, they would get kind of piled up or come closer to each other. Now you can say the car density had increased in that one, and that density increase would come backward from the site of accidents or obstruction, whatever. Now this example I like very much of runner. You just think of some cadets and you put them on ground equidistance, and then you ask one cadet, these are equidistance, although I have not, you ask one cadet who is a very good athlete to start running and touch the cadet standing there, and the instruction to the cadet is that as soon as you feel a touch, you start running also. So after some time, what would happen? After some time, you would see something like this one, that the distance between the cadets is close and the others still are at the same location. So just think of this fast runner as a shock wave. So when this fast runner touch, they come closer to each other, maybe something like this one. So this is kind of a vague idea, but the important thing in here to keep in mind that shock wave is passing through material and material is following the shock wave. The shock wave is passing through material and material is following the shock wave. They are not moving at the same speed. The shock wave or this fast runner cadet moves fast. Those people, those cadets who are touched by this fast runner, they start moving, but immediately they don't take that velocity which the fast runner or the signaler is having.